Sebastian Blanco with Autoblog Green. This question is for both Dr. Samuelson and Dr. Thomas. First, Dr. Samuelson, last year, you and I talked about one of the main limitations about the Irvine hydrogen station you mentioned today, and that was that you can only refuel about 15 vehicles a day there because of a problem with compressing the hydrogen down to a level that the vehicles can use. So the first question to you is, has this been improved at all in the last year, and if so, how? And then Dr. Thomas, how does this situation compare to the 2,300 vehicles per station per day number that you cited when you were giving us your cost estimate for how much hydrogen infrastructure would cost per vehicle? And what are the technologies that need to be invented or refined in order to go from 15 in 2010 to 2,300 a day in whenever?
The answer is no. So there's been no change to the station. It was designed for 25 kilograms per day and is regularly servicing 45 to 50 kilograms per day, so well over design. However, under a award from the California Energy Commission in September that will be placing 12 stations in California in the next year, one of those stations will be expansion of our station to somewhere between 150 to 400 kilograms per day. So around next February, we'll have that additional capacity.
Okay, in terms of 2,300 cars per day, I can show you the calculations that came up with that. But that's the production capability of the steam methane reformer. That's 1,500 kilograms per day of hydrogen production. And the 2,300 cars per day would be using existing technology in terms of compression and storage. As I say, the average refueling time in the NREL experiment for 27,000 refuelings was 4.4 minutes. So you can work through the numbers and see how many cars per day you can put through at that rate.
It sounds like stationary fuel cells, if you have a natural gas supply, are a beautiful thing, and they're out there in the field. But hydrogen has these traits of being very undense. Storage is a real thorny thing, and you get losses in doing stuff like running cryocompressors to compress hydrogen into a reasonable density. So why is this a transportation fuel?
Well, if you look, the Toyota vehicle that's out here was certified by DOE engineers to have 431 miles range on one, there's two tanks, I guess, but on one filling of hydrogen. So it's perfectly adequate for long-range vehicles, so I don't understand your question. It's been proven to be a good transportation fuel. In Europe, I think, we're at 3 million miles. In Europe, there are even greater distances with about an equal number of vehicles, like 156 vehicles in Europe. So, it's been proven on the road experience with ordinary drivers. This is an excellent transportation fuel. So I guess I don't understand your question. In other words, 6 major car companies have designed fuel cell vehicles that have been participating in the DOE Learning Demonstration Program, all of them using compressed hydrogen tanks. And they've all succeeded in packaging them into very nice vehicles.
I just wanted to hear you say it.
Alan Owensman from Bloomberg News. This is for Dr. Thomas and Dr. Samuelson. I'm curious, early in the decade, you had a lot of support from big energy companies, big oil companies, in terms of doing fueling infrastructure. They have pretty much all abandoned ship at this point. Going forward, the automakers all have pretty specific plans to come to market within a few years. What's emerging in terms of a new series of partnerships, alliances with energy companies? Who's going to pick up the slack to actually put the stations in place? Because certainly the federal government is not being overly supportive, and the state of California has limited funds to do it on its own.
Oh, good question. But we didn't talk about your overseas developments. In Germany, they have the High Mobility Project, where they're talking. Let's see, I forgot the exact numbers. I think they're talking about up to 1,000 stations by 2020, and that is a consortium that has, Shell. It has, I forget how many different oil companies and gas supply companies, and all the major automobile companies are part of that H2 Mobility Project in Germany. Japan, they have a similar program going. Look at Hawaii. Hawaii is working with General Motors now. Am I allowed to use General Motors' name here? Well, anyway. To install 20 to 25 hydrogen stations using the existing natural gas pipelines running on Oahu in the vicinity of Honolulu. It so happens they don't have natural gas on Hawaii, they have synthetic gas. But in that synthetic gas is 12% hydrogen today in Hawaii. So General Motors and the gas company in Hawaii are putting in fueling stations where they extract the hydrogen from the natural gas pipelines for refueling cars, and then they put the natural gas back into the pipeline to use it for regular use of natural gas. Methane, of course, they don't call it natural gas there.
Yeah, Alan, I would say that what you've raised is a major challenge today, perhaps even could be described as a crisis of the lack of infrastructure to support the plans of the OEMs to be deploying hydrogen fuel cell vehicles. The declining commitment of the federal government and the declining interest of the energy companies has been frustrating, but it's also created a degree of creativity and efficiency among the stakeholders that perhaps in the end is a silver lining. For example, in the last few years, the automobile companies and the major energy companies, which are not the normal petroleum companies, but the Air Liquide and Praxair and Linde and Air Products, have been working under the leadership of the California Fuel Cell Partnership to have a much more substantial dialogue of information exchange to help support the planning. So that's efficiency. A second reality is something that may not have been expected, but that's the sell-off of gasoline stations by the energy companies to independent franchise owners. That's allowed the Linde and Air Products and Air Liquide and Air Products, all of those, to actually reach out to the independent operators of the Shell stations, the Mobil stations, the Chevron stations, and actually create an opportunity of adding to their business model a dispenser of hydrogen to begin with. And that particular strategy is actually being remarkably successful. And then the third efficiency is the evolution of hydrogen infrastructure planning tools, primarily from UC Davis and UC Irvine, which is allowing the identification of the minimum number of stations that are needed in a community to serve the population, the actual location of those stations within the community of the existing gasoline stations, and then the supply train of hydrogen supply to supply them. And all of that is giving a much more systematic planning strategy, ironically independent of the federal support, but almost as a result of not having a federal support and causing the stakeholders to really rally around and be creative and develop that strategy. Nonetheless, the challenge is still very much there, and the precious contribution of the CEC, California Energy Commission Award of last September, is huge in order to help trigger that initial investment to get to the stations, which right now are anticipated to be 48 in Southern California, to get over the tipping point to allow the retail and commercialization business model to proceed without public support.
Justin might want to jump in on this too and add a little something to it, but John Hanson here. The point is that the major automakers, there are at least 5 or 6 that are fully committed to bringing fuel cells to market by 2015. And they will bring them to market. The product is coming. The question is, what regions of the country are going to be able to support it? So in effect, the automakers are creating an incentive for the development of fuel cells. How quickly they are adopted in any one global region, it's going to be up to those global regions. But the products are coming. They are robust, and it will be a very competitive market with regard to the product. The question is how extensively will each region support the development of fuel cell infrastructure? You brought up the fact that there's a very strong united effort in Europe and, of course, in Japan as well, with 3 of the major automakers. I think it's 14, Justin, of the energy companies as well as MIDI that are involved in this. But the issue really is that the product will come, and it just depends on what regions want to support it.
Yeah, Just to add to that, I mean, as Professor Samuelson has mentioned, the California Energy Commission really, that money from the AB 118 program has been instrumental to kind of kick off this first phase. And so one of the keys is how long is that program going to last, and is there going to be additional funding for hydrogen and hydrogen investments. The current investment plan currently doesn't look so good for hydrogen investments, so there's a big push now to try to make sure there's a balanced approach, because it's about, as we mentioned before, many technologies, not just one, but we need to make sure that the California Energy Commission also understands that and follows that path.
Yes, Jim Motivali. I just had a question of Professor Weimer's program sounds fascinating. I just wanted to know some of the practicalities of that. How much are we looking at the cost of hydrogen from that station, and how much would the station cost to build, and what are the likelihood that it will actually get built? And is it more just sort of is it more kind of an academic exercise to show that it's possible, or are you really trying to get something like this constructed?
So the ultimate end game will be, I think, water splitting using sunlight. In terms of how far we are and what that cost is, one of the critical factors is the cost of installing those mirrors. And the numbers that I showed you were based upon hitting the Department of Energy cost targets for installed heliostats. And the intention is that as CSP becomes developed throughout the Southwest, companies that install those mirrors like BrightSource and eSolar and others, that those costs will come down. Today they are substantially higher than those targeted costs, okay? But the numbers I showed you on the order of $3 to $6 per kilogram, those are the numbers using the Department of Energy heliostat costs. Now, any fuels facility requires a lot of capital, and that's the problem. So I showed you a plant built by Sundrop Fuels, a 1 megawatt facility located in Colorado that is supported by venture capitalists. So there's like $40 million worth of VC money that went into that. But any large fuels facility like a refinery costs $1 billion. And the venture capitalists can't come up with that kind of money. You've got to get a strategic partner. And so really, in order for this stuff to take off, you have to have a major oil or gas company come in and try to get an equity position and try to develop that technology. So it's not going to happen tomorrow. What I've shown is that the technology is doable. We can indeed develop these thin films that are very active, making progress along those lines. But certainly the rollout in hydrogen is going to be with natural gas. It's going to be natural gas, water gas shift, just like was talked about here earlier.